All right, it says how many moles of HCl and NaOH separately are required to destroy the following buffers. So remember that a buffer is a weak acid and its conjugate base, or a weak base and its conjugate acid. So if we don't have any of the weak base or any of the conjugate acid, it's no longer a buffer. So if we look here, if we have 0.325 moles of HF, if we were to add 0.325 moles of NaOH, that would turn all of this HF into F minus. If you have no more HF, it's not a buffer anymore. So buffers are not infinitely able to buffer. You would need to have a range where if you add too much, you'll either use up all of the weak acid or all of its conjugate base in this example. If you want to turn all of the F minus into HF, said another way, have no F minus and no longer have a buffer, you could add 0.225 moles of HCl, a strong acid. Note, I should have said this, but HCl and NaOH are strong acids and bases. So this just forms H plus in solution, this forms OH minus, and it will react with these things. So this adding this much NaOH, 0.325 moles, will turn this completely into F minus, and adding 0.225 moles of HCl will turn all of this into HF. If you don't have both in solution, you're no longer a buffer. All right, what if we have 1.25 or 0.125 moles of methylamine? Well, methylamine is a weak base, so it's going to be destroyed by HCl. Specifically, it's going to be destroyed by 1.125 moles of HCl. Its conjugate acid, okay, the protonated methylamine, if you will. In this case, if we have 0.225 moles of it, we can deprotonate it with NaOH. Specifically, if we add 0.225 moles of NaOH, we'll have none of this left. So essentially, it's how much of this acid and this base will it take to remove any one of these things. Once they're gone, you no longer have a buffer. You just have a weak acid or a weak base or whatever solution.